It's 2026. You're on your commute, trusting the AI system guiding your vehicle. It navigates traffic, reads road signs, reacts with superhuman speed. A stop sign appears. The car sees it, processes it, and prepares to halt. But this time it doesn't. With a flicker of its digital eyes, it interprets the stop sign as a speed limit marker, cruising straight through a busy intersection. No error message. No obvious malfunction. Just a critical, invisible misinterpretation. The only difference was a pattern so subtle, you'd never see it. And that's where everyone is wrong about the security of our smartest algorithms. Our world, as we know it, runs on artificial intelligence. From the complex algorithms predicting global weather patterns to the smart sensors managing city infrastructure, AI is the invisible engine of progress. It diagnoses illnesses with greater accuracy than human experts, secures our digital borders from constantly evolving threats, and powers the logistics that bring goods to our doorsteps. We've built these systems to be fast, objective, and tirelessly reliable, entrusting them with critical decisions that shape our daily lives and our future. They learn from vast datasets, recognize intricate patterns, and predict outcomes with precision previously unimaginable. This ubiquity has fostered a profound, yet often unexamined, trust. But beneath this veneer of infallibility lies a critical blind spot, an Achilles heel inherent in the very nature of how these systems learn. Unlike human intuition, which grasps concepts holistically, AI, particularly deep learning models, operates by identifying statistical patterns in the data it's trained on. They don't truly understand a cat or a stop sign. They recognize a specific arrangement of pixels or data points that, through repetition, they've learned to associate with that label. This reliance on statistical correlation, rather than true comprehension, leaves them vulnerable to a specific kind of manipulation, adversarial attacks. These aren't bugs in the code. They are fundamental exploitations of how AI perceives the world, a perception vastly different from our own. Imagine an artist trying to paint a perfect landscape. What if, with a microscopic, imperceptible touch of a different color, you could convince an art critic that the painting was, in fact, a portrait? This is the essence of an adversarial attack. Researchers add tiny, carefully calculated perturbations, a fraction of a % difference in pixel values for an image, or a few bytes of modified data in an audio file. To us, the original and the attacked version look identical. But to an AI, this imperceptible noise completely transforms its perception. A digital image of a stop sign, with a few strategically altered pixels, becomes a yield sign. A harmless household object, when slightly distorted, is flagged as a weapon by a security scanner. The AI isn't hallucinating. It's precisely interpreting a pattern that our brains simply aren't wired to detect. It's a fundamental difference in perception, a trick on the machine's eyes and ears. The implications extend far beyond academic curiosity. In our AI-driven world, these attacks transition from theoretical exploits to tangible threats. Imagine an autonomous delivery truck misidentifying a pedestrian as a lamppost due to a cleverly placed adversarial sticker. Consider medical diagnostic AI, trained to detect early signs of cancer, being tricked by imperceptible data alterations into missing a critical tumor. Or financial fraud detection systems, meant to safeguard billions, failing to flag malicious transactions because the data was subtly manipulated. Even national security systems, designed to identify threats from satellite imagery or network traffic, could be compromised by these invisible interventions, leading to catastrophic misjudgments. The cost isn't just financial. It's measured in lives, trust, and the stability of critical infrastructure. The cybersecurity community isn't standing idly by. This is an active and increasingly sophisticated arms race. Researchers are developing new defensive mechanisms, like adversarial training, where models are exposed to manipulated data during training, effectively teaching them to recognize and resist these tricks. Other strategies involve refining AI architectures to be inherently more robust, or employing techniques like reinforcement learning to build detection systems that can adapt to novel threats. But the challenge is relentless. As quickly as defenses are engineered, new, more potent adversarial attacks emerge, constantly pushing the boundaries. The very strength of AI, Its ability to learn and adapt also means attackers find new ways to exploit its learning process, making the detection of these fast-changing threats an ever-increasing difficulty. It's an ongoing, high-stakes game of innovation. This fundamental vulnerability forces us to confront a paradox of trust. How do we place unwavering faith in systems that can be so easily, imperceptibly tricked? It raises profound ethical questions about accountability when AI makes a critical error due to malicious manipulation. Who is responsible? The developer? The attacker? The user? As AI becomes integrated into legal, medical, and governance frameworks, these questions become central to maintaining public confidence. Transparency in AI decision-making becomes harder when the very inputs can be invisibly poisoned. Building robust, secure AI isn't just a technical challenge. It's a societal imperative, demanding a delicate balance between rapid deployment and foundational security. The story of adversarial attacks is not one of AI's ultimate failure, but a crucial lesson in its evolving nature. It reveals that intelligence, even artificial intelligence, possesses a unique form of vulnerability. Our reliance on these systems means we cannot afford complacency. The path forward demands continuous, cutting-edge research, robust defensive architectures, and a collective commitment to understanding and mitigating these unseen threats. It means fostering a culture of vigilance, where security is integrated from the ground up, not as an afterthought. Only then can we truly build and deploy AI systems that earn and maintain our unwavering trust, navigating the complexities of an increasingly AI-driven world with confidence, not just blind faith.